This is the third episode of the series on Spring development in Kotlin. In this video, we are going to take a look at logging in Spring Boot. We are going to discuss the two main options we have for logging libraries at this moment, Logback and Log4j2, and also the facade library SLF4j. We are going to showcase the basic usage of SLF4j, then write an XML configuration file for Logback. After that, we are going to switch our project to using Log4j2 instead of Logback and write an XML configuration for Log4j2. If you find this content interesting and you want to support the channel, please like and subscribe. Thanks. At the time I am recording this video, which is early 2022, there are two main libraries that we can use for logging in Spring Boot, and they are Logback and Log4j2. There is also Java util logging, but the Spring Boot documentation recommends against it because of some class loader issues. Now, Logback is the default for Spring Boot, and it's a perfectly fine option unless you have some performance requirements. Log4j2 is newer than Logback, and it is more efficient. If we search for Log4j2, they will go into detail about what they improved from Logback. It says it provides many of the improvements available in Logback while fixing some inherent problem in Logback architecture. And they go into detail. You can read this thing to see the advantages. So more performant, but you need some minimum configuration to switch Spring Boot from Logback to Log4j2. We'll see further in the video how to do that. Another component in the JVM logging environment are the logging interface libraries. And here we have SLF4j, which stands for Simple Logging Facade for Java. And then there's Apache Commons Logging. But Apache Commons Logging has a class loader issue, and it is not recommended. So we're left with SLF4j. Now, with Logback, we cannot use it directly. We have to go through this SLF4j interface. Log4j2, we can use either directly or through SLF4j, but there are some pros and cons for using Log4j2 directly. And let's discuss. So directly, the pros will be that we get more features. So things like custom logging levels, but there are other features that we cannot use if we go through SLF4j. But the main con is that we have less flexibility. Let's say a few months from now, Logback comes with Logback 2, which is much more performant than Log4j2. And then if we want to switch from using Log4j2 directly to Logback, we need to rewrite all our logging code to go through SLF4j. While if we use the SLF4j directly, we would just switch the library in our class path and we would use it right away with zero code changes. And also, let's say we want to split one of our modules from our application into its own library, then it will not be portable enough. Let's say someone is using Logback with SLF4j in their project, then our library is using Log4j2 directly. They will not be able to use it because SLF4j will have two bindings on the class path, so we will need to provide the library with SLF4j. Next, let's see logging in action using a Spring Boot project. So I generated this project using Spring Initializer. It has two dependencies, Spring Web and Spring Boot DevTools. The build tool is Gradle and language is Kotlin. And I added this controller that returns hello world in the -hello path. So if we go to localhost 8080/hello, we see this message here, hello world. If you want to see step-by-step how we created this project and the discussion of initializer and all these dependencies, I recommend watching the first video in the series. There should be a card at the top or a link in the video description. If your project has any of the Spring Boot starter dependencies, then it will have logging enabled by default using Logback. In our case, we are using Spring Boot Starter Web. So if we take a look at this Gradle tab inside of IntelliJ, then we can see all the dependencies on our runtime class path. So we navigate to Spring Boot Starter Web, and inside it, we see the Spring Boot Starter, which is the common dependency for all the starters. And we'll see that Spring Boot Starter brings in Spring Boot Starter logging, which enables logging using Logback. Now, if you are not using any of the starters, then you will have to add the Spring Boot Starter logging manually. So you would go to your Gradle file and add one of these implementation dependencies on a Spring Boot Starter logging. Next, let's try to print some log lines from our controller. So we first need to initiate one logger object, and we'll do it here at the beginning of our class. Let's call it logger, and we need to use the logger factory from SLF4j, which is our logging interface, and then call get logger to create a new logger. And in here, we can either pass a string as a name, but what is more common is that we pass the Java class, and this will create a logger with the name of the class. In Kotlin, we will just use this and class.java. And now that we have this object, we'll try some log lines. And there are basically 5 levels in SLF4j. The first one is trace. Let's call this trace line. The second one is debug. Then we have info. Then we have warning. And finally, error. Let's modify the strings quickly. Debug, info, warning, and error. By default, Spring Boot uses the info level. So by default, trace and debug lines are not printed to the console, are not being logged. They're just thrown away. Trace is very verbose. It is rarely used, only when we're trying to investigate something in locally. Debug is less verbose, but also not being used in production, more for debugging issues. Info is fine. We can print status information. We can see here some example of info log lines from Spring Boot, like the server started on port 8080, live reload is running. So just status information. Warning, usually I use it if something bad happens to the server, but it's not really a problem. And error, then yeah, something critical happened. Someone should look into it. And if my application is being deployed to the cloud and there's a way of monitoring log lines, I would usually put alerts on warning and error log lines. SLF4j also allows for string formatting inside log messages. Let's try one such message. So you'll need to use curly braces in order to add objects, and they can be any objects. I think it will use the toString method on them to add them to the message. So we'll have a number and then a string. And we can also log exceptions together with their stack trace. So let's say we're trying to do a division by 0, which will throw an exception. And then we're going to catch this exception, throwable, and we log it as an error. It doesn't matter which level. And yeah, we'll use this method with a string argument and then a throwable. So let's say error failed to compute X, and then we add the throwable as an argument. And now we just rebuild this module and we'll see the log lines being printed. Because of hot swapping, the server will reload the bytecode. And now if we refresh our API call, we will see all the lines. And in here we see that the trace and debug lines are not being printed because the logging level is set to info. Then we see the info warning and error lines. Then we see the line with the string formatting. Then we see the line where we logged the exception. So we see the specific exception, arithmetic exception, and then the line, file and line that where it was raised, and the complete stack trace. I mentioned earlier that the default logging level in Spring Boot is info. If you need to change this setting for investigating an issue, for example, you can do so from application properties file inside resources. And the property would be logging level root. And let's say we set it to trace for now. And we just need to rebuild the main module. And now if we scroll to the end, we actually see a lot of status information coming from the debug loggers and the trace loggers. That's why it's not a good idea to keep trace or debug on the long term. What we can also do in here is change the logging level to a specific logger. So in our case, it will be our namespace, Vlad save. Then boot3 is our application, and then the name of our class will be hello controller. So this will only set the trace level to our controller. Log lines coming from our controller. We rebuild the module. And now if we refresh our API, we will see that all the lines are printed, including the trace and debug lines. For basic logging configuration, application.properties will work fine. But if we want to do more advanced stuff, we need to write custom configuration files specific to our library. So if we search for Spring Boot logging on Google, we'll open this page from the official documentation. And in here, there will be a section about custom log configuration. And in here it says what files will be used to configure the logger. In our case, we are using Logback, and all these 4 file options will work just fine. But they say when possible, they recommend using the variants with -spring. And in our case, we'll do this file logback-spring.xml. So we're just going to copy the name from here and add a new file to resources, logback-spring.xml. And for now, we're going to erase this logging level line from application.properties. The configuration that we are going to do is that we are going to set the logging level in our controller to trace, and also dual write to a separate file. So we're going to start by looking into the Logback configuration language, Logback configuration. And we are going to look at the appenders. Appenders are the output channels for the log lines. We can have console appenders or file appenders, and there are more advanced things like rolling file appenders. For example, they will write all the log lines from a day into a file, and then we go to the next day, it will write another file, etc. There are many options in here. And for now, so we will need one of these console appenders. This will be the appender for the standard logger in here. So we have this configuration tag, and inside we define different appenders, and then we specify the pattern for the output. And then we will also need a file appender in here. So we'll copy this file appender from here. And for a file name, let's do test-logback for now. So for the root logger, the level will be info, just like before, and the appender will just be standard output. And we will have a different logger Let's look for the logger name. I think it's the syntax. Anyway, I cannot find it. Let's do logger name equals, and now we need to specify the name of our logger with the complete class path. So Vlad save boot3 hello controller, and in here we specify level, and we will set it to trace, and appender reference will be file. And now we start the server. And if we make another call to our API, it should already create the log file. And yeah, we see in here that it has all the lines with trace, debug, info, everything with the exceptions and all. Next, we are going to switch our project from using Logback to Log4j2. Spring Boot has a starter for Log4j2, but the problem is that SLF4j does not allow for two logging libraries being present on the class path. And what we need to do is remove the Spring Boot starter logging dependency and instead replace it to Log4j2. If we search on Google for Spring Boot how-to guides, there's this page with the name how-to guides, and there's an example here on how to perform this swap. And so in Maven we would use exclusions, but because we are using Gradle, we will use module replacement. So first we need to add the Log4j2 dependency, then we need to add this module replacement. So whenever Spring Boot's starter logging is trying to be pulled into the project, it will be swapped with Spring Boot starter Log4j2. So we will copy this Gradle code from here into our project, but we need to change it a bit because we are using the Kotlin syntax instead of Groovy for Gradle. So we just need to add parentheses, and yeah, this should do it. Also remove Spring Boot starter logging. And now we are going to stop our project and reload the Gradle changes. It will take a few seconds for Gradle to rebuild. Now if we start the server, it will use Log4j2 instead of Logback. Lastly, we're going to reproduce the same configuration we did in Logback into Log4j2. So we're going to start by adding a new resource file called log4j2-spring.xml. And this is the name that is recommended in the documentation, is log4j2-spring.xml. And we're going to search for the log4j2 configuration. You have to keep in mind there are two syntaxes for Log4j2 configuration. There's the normal syntax and then the strict one. Make sure you don't mix them in the same file or else it won't work. So we're gonna look into configuring appenders, and we're gonna add, we're just gonna start by adding the configuration tag. We don't need all these attributes, just the configuration. And then we're also going to add appenders in here, appenders. And we need to add one console appender. It will have the name stdout. And also a file appender. It will have the name file. And for file name, we are going to use test-log4j2.log. The pattern is good. And after the appenders section in our config file, we will have the loggers section, and we will have two loggers here. One for the root logger and one for our controller logger. So here it will be com vlad save boot3 hello controller, and the level will be trace. We don't need this, and we need to refer to our file appender. So in here, replace this with file, and also we need to configure the root logger. Also inside loggers, root logger level, we leave it info, and we refer to standard output. Okay, now if we rebuild our main module, we see that already the logging format has changed, and this pattern comes from this pattern layout from stdout. And if we make another call to our API, we will see that it's already writing into our test-log4j2 log file, which is what we expected, and it has the trace level. We see the trace line and the debug line. That's it for today. I will post the source code in the video description. See you next time.